Guys, so today we're getting into lesson 3.2, which is squares, cubes, and roots. So first, some definitions. A perfect square, as I'm sure you guys are aware, is a whole number that you can square root to get another whole number. So for example, 49 is a perfect square since I can square root 49 and get a whole number, in this case 7. A perfect cube works the same way. It's a whole number that I can cube root and get another whole number. So 8 is a perfect cube because I can take the cubed root of 8 and get a whole number, in this case 2. Just so you know, so you have some terminology when we're talking about roots, this little number that's right here, so where this little 3 is on a cubed root, that's called the index of the root. It can be a 3, it can be a 4, it can be a 5, it can be a 6. If it's a square root, then really there's an invisible 2 there, so the index would be 2. You'll never have an index less than 2. Okay, so sometimes you will have to calculate roots by factoring. Now, I'm sure you guys all know how to calculate roots in your calculator. You just press the square root button and then the number, or the cubed root button and then the number. However, in order to be able to do some of the questions that are going to come up in chapter 4, you do have to be able to do cubed roots and square roots and fourth roots without a calculator. You have to do it by factoring. So we're going over it here in our factoring unit, but it is going to come up again and be really important once we get to chapter 4, the second half of this unit. So don't think that you can just kind of shortcut this and plug it into your calculator. You won't be able to do that when we get to the next unit. So the way that you have to calculate roots this time is by factoring. Yesterday, we learned how to do prime factorization. So that's really all that we're going to be doing today. We're just going to be doing it with roots and then taking it kind of one step further. So in this case, I have the cubed root of 1728. My first step is to do the prime factorization of that. So I'm going to divide it by the smallest number possible. So I'll take my 1728. Because it's an even number, I divide it by 2, which leaves me with 864. That's divisible by 2. It gives me 432. That's divisible by 2. It gives me 216. That's divisible by 2. Gives me 108. That's divisible by 2, which gives me 54. That's divisible by 2. Gives me 27. I've got my first odd number. That's divisible by 3. It gives me 9, which is divisible by 3 and leaves me with 3. So all of these 2's plus those last 3 3's are my prime factorization. My second step is to gather those factors into identical groups, and the number of identical groups depends on the index of the root. So in this case, my index is 3. That means I'm going to need 3 identical groups of these factors. Oh, sorry. These factors. Because I only have 3 3's, I'm going to need 1 3 in each of those groups. And then I have 1, 2, 3, 4, 5, 6 2's divided up between 3 identical groups. That means 2 2's per group. So my identical groups will be 2 times 2 times 3, 2 times 2 times 3, 2 times 2 times 3. Each one of these groups is identical, and I've accounted for all of my prime factors. My next step is going to be to write these identical groups as a power. So instead of writing it as 2 times 2 times 3, 3 times, I'm going to write it as 2 times 2 times 3 cubed, because I have 3 of those groups. My next step is to put the power back under the original root. So I had a cubed root originally. I'm going to take that cubed root and put this power, my 2 times 2 times 3, back underneath there. Anytime you have an index of a root that is the same as a power, those are going to cancel out. So in that case, it leaves me with just 2 times 2 times 3. And then my last step is to just actually solve by multiplying. So 2 times 2 times 3 is 12. Okay, so I've just followed these steps. I've done my prime factorization. I took my prime factors and grouped them into 3 identical groups because my index was 3. I then wrote those groups as a power. So I just took one group and put it essentially to the power of the number of groups. I then write that whole power underneath the original root sign, in this case a cubed root. If you've done it right, your index of your root should be the same as your power or your exponent, so they'll cancel out. And then I just multiply whatever is left. So really you're just taking one of those original groups, multiplying them all together. The reason I've shown all of these steps when you could just say, oh, I'll just take 2 times 2 times 3 and get the answer. Again, I'm showing all of these steps because the numbers we get in this unit will all be perfect squares or perfect cubes, so it'll work out nicely. However, once we get to the next chapter, we're going to be dealing with non-perfect cubes and non-perfect square roots, non-perfect squares, non-perfect cubes. And so you will actually have to do all of these steps. There won't be like a shortcut that you can take. So learn all of the steps now, practice all of the steps now, and it'll make it much easier for you once you get to the next chapter. Okay, let me know if you have any questions about this.